Good morning. Myself Prabha Aranje, working as an assistant professor in EC department at SNS College of Technology. In this lecture video, I am going to discuss about the fast Fourier transform topic from the subject is digital signal processing. Let me see. Yeah, to overcome these three problem, we are using fast Fourier transform. The problem is first is conversion from time domain to frequency domain is slow, and second problem is cannot able to apply the for vast applications, and third problem is filtering of the signals is also a slow process. To overcome these three problem, we are using fast Fourier transform. Here let a small introduction of fast Fourier transform. The fast Fourier transform is a family of algorithm that calculate efficiently the discrete Fourier transform, DFT, and the DFT is also a sequence capital X of k, which is the frequency domain. This efficiency of the fast Fourier transform is at a maximum when the length of the sequence is a power of 2, that is capital N equal to 2 power p. If the n equal to capital N equal to total length of the sequence capital N equal to 8 means the p value should be 3, p equal to 3, which is 8 equal to 2 power 3. P is a positive integer. The complexity of FFT algorithm is n logarithmic of n. This is the just graph of fast Fourier transform, which means time domain to frequency domain. In fast Fourier transform, we are using two type of algorithm. First one is decimation in time algorithm, and second one is decimation in frequency algorithm. In this video, we will see decimation in time algorithm. This is the radix to decimation in time algorithm, a butterfly diagram for radix to decimation in time algorithm FFT. There are basic diagram. There are two inputs. First is small a and small b, and output for small a is capital A, and output for small b line is capital B. The cross here we are using radix to DIT, so only one class, and Wn of r is nothing but the twiddle factor. We already we discussed the twiddle factor. Wn of r equal e power minus j 2 pi divided by capital N. This is the mathematical expression for twiddle factor, and upper point of radix to DIT is a capital A equal to a plus b, upper lower point a minus b multiply with twiddle factor. And this is the butterfly diagram for 4-point decimation in time algorithm. Left hand side is input sequence and right hand side is output sequence. First cross is first stage of the first. Here you can see the first stage and second stage, and bit reversal ordered input sequence mapped to the first stage, that is x of 0, x of 2, x of 1, x of 3, and then output of corresponded x of 0, corresponded x of 2, and output of the first. We find the output of the first stage, which is the input of the second stage, and finally we get the second stage output is the final output. We will get the second stage output, which is the final output of the 4-point sequence. This is the 8-point FFT, DIT FFT. Bit reversal order is x of 0, x of 4, x of 2, x of 6, x of 1, x of 5, x of 3, x of 7. and output is final output is third stage output is final output. Here you can see the three stage. First stage output is second stage input of the second stage, and output of the second stage is input of the third stage, and output of the third stage is final output. Yeah, this is, you can see. Yeah, this is the bit reversal order. Original input sequence is x of 0, x of 1, x of 2, x of 3, x of 4, x of 5, x of 6, x of 7. The binary form is here you can see 0, binary form for 0, binary form for 1, 2, 3 up to 7. Binary form of 7 is 111, and reverse order. Just write the reverse order of this binary form. For example, reverse order of 1 is 100. That means 100. What is the value of decimal value of 100 is 4. This is the bit reversal order. For one bit reversal order of 1 is 4. Bit reversal order of 2, which means x of 1, x of 4. Bit reversal order of 3 is 6. X of 3, bit reversal order of x of 3 is equal to the bit x of 6. Like, okay, complex multiplication. Each inner product requires n number of complex capital N number of complex multiplication. There are n inner product, hence we require n square multiplication. However, the first row and first column are all ones and are should not be counted as multiplication. There are two capital N minus 1 such instance. Hence, the number of complex multiplication is n square minus 2 into n plus 1, that is n minus 1 whole square. Complex addition, whereas complex addition is each inner product require capital N minus 1 complex additions. There are n inner product, hence we require n into n minus 1 complex addition number, which means total number of complex multiplication used in this FFT is n minus 1 whole square, and total number of complex addition used in this FFT is n into n minus 1. This is the one example problem of 4-point DIT FFT algorithm. Bit reversal input order is 1 input sequence x of n equal to 1, 2, 3, 4, and bit reversal ordered is 1, 3, 2, 4, and output of the first stage is 4 minus 2, 6 minus 2. Output of the final stage is 10 minus 2 plus 2j minus 2 minus 2 into minus 2j. This is the total output, that means total frequency domain output of this 4-point DIT FFT algorithm. Okay, this is the main difference between direct computation and using radix 2 FFT, using FFT algorithm. Direct computation require a large number of computation as compared with FFT. This is the main difference. FFT algorithm processing time is more and more for large number of capital N, hence processor remains busy. In direct computation, processing time is very less when we are using FFT. Direct computation does not require splitting operation. Splitting operation is, whereas splitting operation is done one time domain basis, DIT or DIF. This is the main difference between direct computation and FFT. If you have any doubt, you can ask me through the comment. We will meet in next video. Thank you.